Welcome back, everybody. So today what I wanted to show you is something I've been working on for the last couple of weeks. I'm hoping it's going to be a major feather in everybody's cap, so I'm giving it away for free. Basically, I've developed this system over many, many months, possibly a year, actually. We've been bashing away at improving this one for a very long time. I've been testing it on various different LLMs. It does work with all of them. However, some of them fail to grasp some of the features. It's using my adaptive capacity elicitation thought process method, which is a specific methodology which I developed to in a ChatGPT assistant. It also works in things like Gemini, but basically I find it works best over in Claude. So I'm going to show you how we actually use that. So obviously I'm going to take the actual file, which you'll find linked in the description. Let me see if I can just find that file real quick. There we go, aceholofs.v3. So it's not just the elicitation. It's that, like I said, the ACE system makes it think a lot more. So there's a priming stage, a comprehension tracking stage, a context clarification stage, and then it expands the elicitation by redeploying the prompts and designing new ones with increased complexity, all within the scope of what we've defined. And then it does recursive ascension, which is a virtual loop to repeat comprehension tracking through expanding elicitation again. And it'll do that many, many times to get to its final conclusion. Now, the problem with the system was that because it was so output wordy, the outputs would somehow cloud the ability of the LLM to operate cleanly. So it would start hallucinating based on the contents of its own research. And I think that we've now figured that out with the holographic file system. Now, you may have seen virtual CLI done with LLMs before, and we're essentially making that a core component to take on board the weight of the elicitation. So what I'm going to do is I've got the prompt on the screen right here. I'm just going to make it bigger so you've got a chance of being able to read that maybe. And like I said, I will be giving this away in full. I'm going to copy the whole prompt into the description, and I'm going to put a link to a text file or something, probably a Pastebin or a Google Drive, whichever way, it doesn't really matter. Now, what I recommend you do is you just take this as a text file and just drag it straight in. And then I could say, it should just work. If I now ask it to do a task and use ACE methodology with HoloFS, which is pretty much what I call this, it's actually going to give you access to things like create, write, append, read, list, delete, and rename. Those are for files which you create, but obviously it's going to create its own files inside this sort of virtual file system. I call it a holographic file system because it's only existing. It also works in a hybrid way, so you don't actually get the file system the whole time. You don't have to know how to operate a Linux system because it will still work in a conversational based way. So it's going to sort of semi-auto between using this virtual file system, which, like I said, I'm calling the holographic file system, just to differentiate it from a virtual file system, which is something completely different. You see, in a virtual file system, you have an actual file which you can take away. With a holographic file system, you do not. Until we get a deterministic LLM with some kind of seed control, it's almost impossible to guarantee over time that the contents of these files will actually be identical. However, that can actually be quite an advantage if you're trying to get some variable output. So, for example, in the context of making prompt lists for image generation, you might actually want to have a non-fixed fuzzy data to pull from. In other words, it's regenerating the details every time it pulls from them. And therefore, the variation is actually going to make your prompts that you generate more varied, which is actually advantageous in that task. So we've already spoken about the integration. So for the duration of the conversation, you'll be able to juggle all the generated data and analyze any of that information. But crucially, we can actually delete files. So because everything is stored in a file in a virtual file system, we can identify where an error might be, delete it, and it will no longer affect the, it won't affect the cognition. Okay, so I put it to work on a basic prompt. Please use ACE with HoloFS to return highly detailed prompts for use with image generation AI. Image descriptions should be both unique and varied. And this is what it's returned. First of all, it started off by doing creating a directory in the file structure called ACE image prompts. It then went in there and created priorities.txt, prompts.txt, responses.txt, and logs.txt. It then started going through the ACE stages. So first, it decided to define priority capability. So here we have it doing an echo, vivid sensory details, unique conceptual combinations, varied artistic styles, emotional evocation, and narrative implication. That's going into priorities.txt. Then for priorities text, it's doing while read, do, generate an image prompt focusing on priority to prompts.txt. And it's then doing cat prompts while read, prompt, do, generate prompt, responses.txt. Once that's finished, it's going to do context clarification. So then it's going to do the components of an effective image prompt. It's going to break that down, put that into prompt components.txt. Now it's going to start expanding elicitation by looping the previous stages and then continuing to build up a wealth of data. Okay, now it's going to write itself a recursive loop. So for I in the list, it's going to do in length, I guess. Iteration logs text, it's going to cat prompts.txt, refine and expand to prompts.txt, refined prompt, simulated refined prompt to responses.txt. It's going to then analyze responses for the iteration to logs.txt, and then it's going to review the results. So echo final prompt analysis, analysis.txt, cat responses, and then eventually analysis.txt. So here we have let's see, there's detailed generation prompts, right? And as you can see here, you've got everything. Now, if I was to say ls, it's going to show me all of the files in the current folder. So remember, I'm not in, ACE image root. So if I go cd ACE image prompts, let's go in there. Oh, there's a typo. Yeah, I forgot. I typed it wrong. All right, let's just do that right. Come on. Oi. Have I still got a copy buffer? Right. So, right, and then I want to do ls again, this list system. So this is like a Linux command, right, for like dir. Okay. So it'll show me what's in there. Now, as you can see, I've got analysis, logs, priorities, prompt. So let's do read logs.txt, right? Let's see what it's been doing with itself. It says, oh, look at all this. Here's the contents. Iteration 1, analyze responses, iteration 1. Reading through the existing prompts, refining and expanding each prompt, simulating the generation of new prompts based on refinements, and then analyzing the responses. The log is quite concise as it's just tracking the completion of each iteration. Okay, would you like to examine the contents of another file? Prompts or responses? Yeah, I'd like to, yeah. So let's say read responses.txt. And then we've got all of these. Look at that. Look at this. Refined prompt, simulated refined prompt. This is why I'm calling it a holographic file system, because the data is there. You can see the image outputs over here. These are the prompts which it's done. So it's quite interesting. I don't know why it's labeling them subject, mood, colors. It shouldn't be doing it like that, but that's just a case of me telling it what to do and not having told it what to do. But I hope you can see that the higher cognitive ability of ACE methodology is working great with this. So what I wanted to show you was how when we have a file and we delete a file, it drops everything in there, but I don't think I'm going to be able to show you that example right now. I wanted to make this a quick video, but I did want you to have a good idea of what this is doing. So as you can see here, what it does is it gives you a virtual file system which you can script, or you can have it script for you, because it does work as a conversation still. Okay, so this is drift from the future. Basically, I've already finished creating this, but then since recording the video, I have improved it. So I now have a second version of the script, which I'm going to be explaining in this video, Ace HoloFS v3 prompts. This one has been slightly altered for the task of making interesting prompts. Now, if you see here what it's actually doing, it's been tasked to create 10 highly detailed prompts which span noir and science fiction aesthetics. They must be single line of natural language and under 1,200 characters each. Store them in a text file for easy retrieval with Holographic Filesystem, HFS. Ensure ACE methodology is used to create each individual prompt. So, as you can see, it's gone ahead and it's started operating its virtual file system to use ACE methodology, as I will explain or have explained, depending on where I put this in the video. And then by the end of it, it's going to give me the prompts, which are sci-fi prompts. And here they are over on the right-hand side, and they are less than 1,200 characters and highly detailed. So I'm going to be throwing them into an image generator and see what they look like. However, just to note that the prompts version can be used like this. You throw the text file into the AI and then you use a prompt, which is like this. But, so for example, the particular image model I'm using likes to have about 1,500 characters per prompt. I want 10. I want them. This is my order effectively, right? But you must say, well, you don't have to. You just get better results. If you say store them in a text file with the holographic file system, that takes advantage of that. And then ensure ACE methodology makes sure that it does its full cognitive load for actually generating the prompts. It doesn't do any weird shortcuts that take less effort, because some of them can be quite lazy. And then, like I said, I've got my prompts here, so I'll chuck them into a prompt list and generate some images and see what they look like. But this can actually do just about anything. Obviously, if you use the base, it doesn't have to make image prompts, okay? It can make prompts for any kind of... It doesn't even have to make prompts, okay? Here's the changes, by the way. As you can see, there's a few extra natural language review rules and natural language output directives. And so in that way, it's going to not look quite as chunky as it did on my first demo there. But like I said, it's easy to customize this. This is essentially like a kernel. It's like the primer, which is going to make sure that you're going to get full cognitive load. So it's not going to cheat and give you cheap answers. But then also it's giving us this virtual, like I said, I call it holographic because you're projecting it. It doesn't exist when the conversation is over. And until we get deterministic prompts or deterministic outputs, or unless you have a setup that provides you with deterministic outputs, you're not going to see the same information being held there over time, because its attention, its ability to remember what was there. We're effectively exploiting the fact that it has a really good memory and a really good ability to juggle. And also, if the deterministic setup arrives, we'll be able to say, well, hang on a minute. We can just regenerate the data exactly the same every time, so then I don't even have to have a file. Now, this could actually go a long way, but I'm just keeping it to the file system for now, because that's an easily manageable thing. But imagine if we had a seed for our network driver. So you don't actually have network drivers even. You could have AI project them holographically from a seed. And as long as you've got the right seed and the right prompt and the right model, it's going to give you the same file every time, at which point you could have system drivers being holographically projected by AI on runtime. And I think that's, yes, so you could keep all of it in latent space. And I think that this is something which we're going to see more of, because I'm scratching the surface with it. That means other people must be. But certainly in our little corner of the internet, we can use it for making hyper-realistic, hyper-detailed prompts, and we can start tuning them as well by adding additional directives and so on, as I have done with this one for image prompts. Okay, so I'll insert this somewhere in the video, because I actually recorded it after I was done. There it is. So there'll be 2 files. Okay, and one of them has been already optimized for prompting, but I do encourage you to start with the base and adapt it So load it into Claude and say, hey, how can we change this? A key thing to say would be, missed it. Let's go to the bottom. A key thing would be, so show the fully distilled complete prompt, which can be used for clean new conversations. That's something you want to do after working with it. In order to modify it, so this is the original distilled guidance. How can we seamlessly integrate the NLP additions to this? So this is me asking it to tell me how it wants to hear the rules. Because instead of telling the AI how you want to tell it, ask it how it wants to be told. It'll happily do that. And then we can make sure that we're speaking the same language. And then you'll get more out of your commands to the AI as well. So the reason for the oversight was because I didn't give an accurate enough task. So tasking the AI is quite important. So I have been quite precise with my task. But clearly, you could give a different task to the base program, and then you could adjust it by supplying it again, put the base back in, right? And then tell it to fix it for you, essentially. We're going to do much more with this in future as we start integrating more LLM stuff into our image generation workflows. However, for now, I think I'll leave it there. And it allows you to have it make everything into files, which you can then read out or delete. And then obviously you could edit them too. But what it does is it stops it from getting confused by its own outputs, because normally it just chugs it all out into the chat. And you don't want it doing that. You want it to put it into these holographic files, which when you actually look inside of them, often they contain just references to other files. I believe what's happening is it's juggling the data in latent space, and then it's potentially reimagining the data every time. Now, obviously, if we have a deterministic LLM, it's going to regenerate the same data every time. So that would be the natural next step for this system. Until then, I want to give away this sort of prototype for you guys to have fun with. Obviously, you can change the rules. But the main thing is advanced garbage collection, which stops the attention from wandering and makes sure you have clean outputs. So there it is, guys. Thanks for watching, and I'll see you next time.